Hello and welcome back. In this video, we're going to look at an introduction to probability. Well, one question that may come up, what is probability? Well, probability is a calculation tool used to answer important questions whose answers are unknown. It's useful in very many fields. This includes science, this includes industry, this includes the medical field, this includes legal, and this includes engineering. We've already looked at using probability in a way. If you return to the video where we discuss the idea of relative frequency. If you haven't seen that video, you should pause and go back and watch it now. Remember, relative frequency was the number of times an observation occurred divided by the total number of occurrences. But in order to understand probability, we first need to understand several basic ideas related to the basic principles of counting. The basic principle of counting says that suppose we have, I'll keep it simple, two experiments, E1 and E2. And if E1 can result in any of m possible outcomes, and if for each outcome of E1 there are n possible outcomes of E2, then the basic principle of counting says there are m times n possible outcomes of the two experiments. For example, suppose I have two dice, one red maybe and one blue. I'll call the first dice D1 and the second dice D2. Perhaps D1's red and D2 is blue. D1 has 6 possible outcomes. It can land on 1, 2, 3, 4, 5, or 6. However, for each of these outcomes, D2 also has 6 outcomes because it can land on 1, 2, 3, 4, 5, or 6. Therefore, rolling both dice, we get 6 times 6. That's 36 possible outcomes. We also need to discuss the idea of what are called permutations. These are ordered arrangements of some object. Here, order matters. As an example, how many different ordered arrangements of the letters A, B, and C are possible? Well, clearly we can see that I could write this as ABC, ACB, BAC, BCA, CAB, and CBA. Each of these arrangements is a permutation. So here I've got my original, which is ABC, but this can be considered a permutation. Now, if I rearrange the letters to ACB, this is a permutation. So there are 6 ordered arrangements. I can permute these letters 6 ways. We can look at this from a mathematical standpoint, however. We saw there were 6 possible permutations when we listed all of these out. How might we do this mathematically? Let us think about the ways we can choose the first letter. I've got A, I've got B, or I've got C, so I could choose A first, or I could choose B first, or I could choose C first. So there are 3 ways to choose the first letter. And once I've chosen this letter, now there are only 2 ways to choose the second. So suppose I chose B first. Well, I could then choose A and C, or I could choose C and A. Those are the only 2 ways. And after I've chose the second letter, there's only one way to choose the last letter. Now, if we look at the basic principle of counting, we said there are m by n possibilities. So we have 3 times 2 times 1 possible choices. And this is called a factorial. Here we have 3 factorial choices, where this exclamation point denotes our factorial. So here we've written 3 factorial. That is 3 times 2 times 1. In general, if we have n objects, and we have n factorial different permutations of these n objects, then we're going to say that n factorial is equal to n times n minus 1 times n minus 2 times n minus 3 times ... all the way down to times 3 times 2 times 1. Let's suppose for a minute, instead of wanting to know just how many ordered observations we could get, suppose instead we'd like to know the number of different groups of R particular objects that can be formed from a total of n objects. As an example, suppose I wish to know how many different groups of 10 students I can choose from a class of 36. Well, we'll get back to that example. Let's make it a little simpler. I'd like to know how many groups of 3 letters can be selected from the letters A, B, C, D, and E. But here, order doesn't matter. We could have ABC, ABD, ABE, ACD, ACE, ADE, BCD, BCE, BDE, and CDE. We need to recall the basic principle of counting. I've got 5 letters, so there are 5 factorial ways to select the groups. But again, I said order doesn't matter, because ABC is the same as ACB, is the same as BCA, is the same as BAC, is the same as CAB, is the same as CBA. In other words, if I look at Tom, Jim, and Bob, those same names, Bob, Jim, and Tom, doesn't matter. I've chosen those 3 individuals. So if I look at just doing 5 factorial ways to select the groups, I've overcounted each group 6 times, because here there are 6 ways, right? There are 3 factorial ways that I can choose 3 letters. If I simply look at 5 factorial ways to select the group, I've overcounted each group of 3 6 times. Since we've overcounted these groups 3 factorial times, we need to account for this. And the way we're going to do that, we're going to say that we've got n factorial individuals. However, we have r factorial groups we'd like to choose, and then we have the remaining n minus r factorial left over. And so what we're going to say is that the number of possible combinations of size r chosen from a group of size n is given by n choose r. That is n factorial divided by n minus r factorial times r factorial. So let's return back to our example that I mentioned a few minutes ago. I'd like to know how many different groups of 10 students I can choose from a class of 36. Here, n is my total number of students in the class, 36. R is how many I'd like to have in my group. There are 10. And then n minus r, that's 26. And so using this formula for combinations, we can see we've got n factorial over n minus r factorial times r factorial. That is 36 factorial divided by, well, 36 minus 10 is 26. So we have 36 factorial divided by 26 factorial times 10 factorial. 36 factorial divided by 26 factorial times 10 factorial gives us 36 times 35 times 34 times 33 times 32 times 31 times 30 times 29 times 28 times 27 times 26 factorial. Notice I stopped at 26 factorial. And that's because I have a 26 factorial in the denominator. And I can cancel everything in this 26 factorial with everything in this 26 factorial. And so that leaves me with 36 times 35 times 34 times 33 times 32 times 31 times 30 times 29 times 28 times 27 divided by this 10 factorial, which is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And now we can begin to cancel things, such as perhaps 10, we cancel the 30 with the 10, and that would leave a 3. And perhaps the 27 and the 9 cancel, and that would leave a 3. And 8 and 32 would leave a 4. And 7 and 35 would leave a 5. And 6 with 36 would leave 6, etc., etc. Now, these cancellations can be done numerous different ways. This is not the only cancellation that you need to use. However, when I canceled these, I got 6 times 7 times 34 times 33 times 2 times 31 times 3 times 29, and that gave 254,186,856 different possible combinations of 10 students that I could choose from a class of 36. And if we now return back to our relative frequency, how many ways can I choose that one group of 10? Well, there's only one way. There's only one way that group of 10 exists. And so the probability I choose these 10 names is 1 out of 254,186,856. There is, however, a stipulation, because each group must be equally likely. And each individual also needs to have the exact same chance of being chosen. So each group must be equally likely. Well, that means that each group has to have the exact same chance of being chosen. How might we do this in R? If we begin with our multiplicative rule, we'll keep this one simple. I've got a two-sided coin. One's red, one's blue. A's got 2 sides, B's got 2 sides. And so A times B is simply 4. Perhaps I have 3 die. E1 is red, E2 is blue, E3 is green, and they are each 6-sided fair die. And so how many possible outcomes do I have? Well, that is E1 times E2 times E3, and that is 216. What happens if I want to roll these 3 die and toss one of these coins? How many outcomes do I have in this? Well, I've got E1 times E2 times E3 times, we'll just roll coin A, and that gives us 432 possible outcomes. Our permutations, again, our ordered arrangements. As an example of a permutation, here I've got X is 1, 2, 3, and I want to sample X. And this is one permutation out of all permutations. Remember, there are 6 permutations here. How do I determine the possible number of permutations? I want to use the factorial function, factorial n. Well, here X is 3, so if I do a factorial of that, I get 6. Suppose instead n is 12. When I run my factorial, I have 479,001,600 possible ordered permutations. Well, now what about combinations? Remember, our combination is n factorial divided by r factorial times n minus r factorial. And so in our example of our 5 letters, we're going to let n equal 5. We're going to let the number of letters be 3. Then n minus r is what I've called nr. That's 5 minus 3. We'll run this, and then we can use this factorial function, factorial n, right? N factorial divided by r factorial times n minus r factorial, and that gives us 10. But there's a slightly easier way to do this. We can simply use the choose function. Choose how many total, how many in the group. So I'm going to choose n and r, and I get 10. So now let's go to our last example where we have our 36 students. We wish to choose 10. I'm going to have n is 36, r is 10, nr is our n minus r. And then when we look at our combinations, we get 254,186,850. Suppose I have 36 students, and I get the first 10 who walk in the class to walk in and write their name on the board. And after all the students come in, I then have everybody write their name on an individual piece of paper. I put it in a hat, I shuffle it around, and then I randomly sample 10 names. And I'd like to know the probability that I randomly sample the same 10 names that are written on the board. Well, again, there's only one way to obtain the sample that's on the board. So 1 over n choose r. And that gives me 0.000000003934,114, which is written as 3.934,114 e to the negative 9. All of these groups of 10 are equally likely to be chosen, and they all have positive probability. That's it for this introduction into probability using counting methods. In our next video, we will continue our discussion of probability. See you then.